Section 11.2. Our objective today is I can apply the theorems for areas of parallelograms, triangles, and rhombuses. So with a parallelogram, so let's say I have this parallelogram. The base, any side can be the base. So this could be base 1, this is base 2. And the height is the altitude from any base to the opposite side. So for instance, this is an altitude, which we also call the height, or I could extend this line, and so this could be the altitude or height of the parallelogram, okay? But if the parallelogram was turned the other way, then I could call this the base, and then this would be the altitude or height. So with a parallelogram, you have to be very careful which side you're calling the base and which will be the height. Okay, and let me show you a really exaggerated one. So let's say that I have a parallelogram that looks like this. Okay, well, you can tell that if I say that this is base 2 and this is base 1, and because it's a parallelogram we know that they are congruent, then this would be my height or altitude. Okay, but if I call this base 1 and this base 2, then you can see that the altitude or height is going to be much different. It's going to be a longer height. So that's why you have to be very careful which you call the height and which you call the base. You have to be very aware of which is which. Okay, so our first theorem is for area of a parallelogram. So it says the area of a parallelogram equals the product of a base and the height to that base. Okay, so, and as I showed earlier, whichever you designate for base, that changes where your altitude or height is. And so basically the formula is area equals base times height. Okay, so an example is if I have this parallelogram, and this is a 30-degree angle, this is 8, this is 12, and my height is right here. Okay, well, this is again a 30-degree angle. Well, then I can use my 30, 60, 90. So if this is 30, then I know that the hypotenuse is twice the short leg. So if I divide 8 by 2, that's going to give me 4. So this is 4, and then I know, whoops, I'm sorry, the height is 4, because that's opposite the right angle. And that's all I need to find the area. So then the area of this parallelogram is base times height. The base is 12 because opposite sides of parallelograms are congruent, so I know this is 12. And the height is 4. So the area of this is 48 units squared. Okay? Right. Theorem number 2. it says the area of a triangle equals half the product of a base and the height to that base. Okay, and so an example of this one, might be something like this. So I have this triangle, and I know that this is 10, this is 10, and this is 8, and this then is going to be my height. Well, because it's an isosceles triangle, I know that the altitude here bisects the opposite side. So I know the side is 4, and so then I know that I have a right triangle, so I know that 4 squared plus h squared has to equal 10 squared. So 16 plus h squared equals 100. So h squared equals 84. So h equals 2 square root 21. Okay, so then the formula for area is 1/2 base times height. And remember, that can be written different ways. Base times height divided by 2. So my base, the area then is 1/2 times my base, which is 8, times the height, which is 2 square root 21. So that's going to be 8 square root 21 units squared is the area of the triangle. Okay. So example 2, if I have a triangle that looks like this, where this is 5, and if I drop an altitude from here, I know that is 4. And so the area of this triangle is going to be 1/2 times the base, which is 5, times the height, which is 4. So that's going to be 10 units squared. Okay, and remember, on a right triangle, the legs are considered the height and the base. Okay, so if you have a right triangle where this is 12, this is 5, this is 13, then 12 is my altitude or height, and 5 is my base. So it's going to be 1/2 12 times 5, or 6 times 5, or 30 units squared. All right, then we have a special case. So a rhombus, remember, is also a parallelogram. And so we can use the formula for a parallelogram on a rhombus. But it turns out that there's also another way to find the area. So on a rhombus, we have 2 choices depending on what information we know. So the theorem says the area of a rhombus equals half the product of its diagonals. In other words, area is equal to 1/2 d1 times d2. Now remember, with a rhombus, remember a rhombus is defined as a parallelogram with 4 congruent sides. But remember, what's special about a rhombus is that the diagonals of a rhombus are perpendicular to each other. They also bisect each other. Okay, and so we can use that, what we know about rhombuses, to find the area. So for instance, example, let's say I have this rhombus where this side is 5. I have this diagonal and this diagonal, and I know that this length is 4, and I need to know this length. Okay, well, I know that if this is 4, then this has to be 4, right? And I know that this is a right angle, and so therefore I can find this length by using Pythagorean theorem. So I know that 4 squared plus x squared has to equal 5 squared. So 16 plus x squared has to equal 25. X squared has to equal 9, so x equals 3. So x equals 3, that means this part is 3. And so then this whole diagonal has a length of 8, and this whole diagonal has a length of 6. And so I can use our new formula and say area is equal to 1/2 6 times 8. So 1/2 of 6 is 3, 3 times 8 is 24, so 24 units squared. Okay? But if my rhombus, if I have this rhombus, and I know that this is 8 and this is 60, then I want to use the formula for parallelogram, because I know that this angle is 60 degrees. I know all these sides are 8. And so then I know that this is my 30-degree angle. So half of 8 is 4. And then 4 times square root 3 would be my height. So in this case, I would use area equals base times height. So my base is 8, my height is 4 square root 3. And so that would be 32 square root 3 units squared. Okay, so on a rhombus, you can use either formula. It just all depends on what information you have.